So what we're looking at is f of x is equal to 2x squared plus 3x minus 3. That's a table that basically for that function. So if you were setting up a t-bar chart. I want to find the limit as x gets closer to 1, what happens to y? Notice, x is getting closer to 1. 0.9, 0.99, 0.999, 0.9999. Is x equal to 1? No. If I look at the other side, 1.1, 1.01, 1.001, 1.0001, is x equal to 1? No. Given where x is going, here are the y values, where do you think y is going to end up? Yeah, 0.999 is very close to what number? 2. 0.007 is close to what number? Or 2.0007 is close to what number? 2. If you had to make a guess, when x equal 1, where's y going to be? 2. That's the best guess. The best guess is going to be y equal 2. Well, x equal 1, y equals 2. It happens to be the y value at x equal 1. Now, okay, everybody give me 2 fingers. I know this is going to seem stupid and silly. We're going to be coming on looking at the most missed problem on the first test. And all it takes is 2 fingers to be able to get it right. 2 fingers. Now what you do is, follow me. Take your 2 fingers and put them on the graph. Move in from the left to that red dot. Move in from the right to that red dot. So I'm essentially on a graph now doing the table. As x gets close and close to 1, y is getting closer and closer to what number? 2. As x gets closer and closer to 1, y is getting closer and closer to what number? 2. My fingers actually meet at x equal 1, y equal 2. That's the limit. So where do they meet? Or appear to meet? Or you think that's where they're going to end up meeting because they're so close. I blew this up because all I'm interested in is being very, very, very close. Now if you take a look at the numbers, 1.9993 is very close to that dot. It doesn't touch it, but it's close. 2.0007, same thing. If I were to guess, if my fingers continue on, they would end up at that red dot, which is x equal 1, y equal 2. Where they touch, or appear to touch, is at that y value is the limit. And I'm coming in from either side of that x value. Now, I like to kind of look at it also, another way. Suppose I had 2 ants. And think about this. You have these 2 people running down the beach, right? That's that commercial. Running toward each other. And you see one person running, and then they get to the other person that's running. Right? And you're going to say, are they going to meet? Maybe yes, maybe no. You don't know unless you see the whole thing, right? So here's Howard. We have to have a name for Howard. And he's running toward that red dot. Now here's Harriet. And since Harriet's a girl, let's put a bow in Harriet's antennas. She's running toward that red dot. The question is, do Howard and Harriet meet? Yeah. They get close enough, right? It's like me reaching up and feeling the little electrons on that little thing up there. It's like, I get close enough to almost touch it. But if you were to look from afar, it looks like I am touching it. Even though I'm not, but I'm so close. So Harriet and Howard and Harriet will get close enough that I could call it that they actually meet. Even though perceptionally, if I got close enough, they may not. Harriet and Harriet are my fingers. Use your fingers. So we're going to be looking at the limit in this case is y equal 2. So as x approaches 1, and I'm going to use this for the word approaches, y approaches 2. They may never get there, but in my field of vision, it looks like they do. Here's the thing that's going to drive us nuts. Suppose I have f of x is equal to x squared plus 2x minus 3 over x squared minus 1. We want to take a look what happens as x approaches 1. Well, if I put x equal 1 in, what will happen is I get a 0 over 0 form. 0 over 0 form says, I don't know. Haven't a clue. It's called an indeterminate form. Anytime we have an indeterminate form in this class, it's going to scream a word at us. It's called algebra. That means if I want to know what this thing does, I'm going to have to use algebra in order to find out. However, I could set up a T-bar chart, and at x equal 1, since I'm dividing by 0, I'll get an error message. However, if I avoid that and say I'm going to get very, very close to x equal 1, here's x coming in from the left-hand side. I'm very, very close to x equal 1. And notice, what's the y value? Very, very close to y equal what number? 2. Come in from the other side. I'm very, very close to x equal 1. And the y value looks like it's getting very, very close to y equal 2. So from all appearances, it looks like that y is going to be 2. That's where y is going. So if I take a look at the picture, this is the picture. There's a hole in the graph. There's a hole in the graph at x equal 1, y equal 2. However, fingers, I'm going to be doing a lot of this, especially with the group work that's coming. I run along the graph. For all intents and purposes, it's going to look like I'm going to end up at what y value? 2. Do I care there's a hole there? No. How big is the hole? Itty bitty, itty bitty, right? It's so itty bitty that from all intents and purposes it looks like I'm there. Because it's teeny, teeny, tiny. So even if there is a hole there, it's going to appear as though I'm at y equal 2. So as I'm looking at Howard and Harriet, put a bow in, so we know the difference between Howard and Harriet. I guess that's rather sexist, but that's okay. I guess Howard could wear a bow. So and at which point they're coming along, as far as we're concerned, they meet. It looks like they do from a distance. I get in very, very close, it's going to appear that they don't. But from a distance, it looks like that's where they're headed. See, it doesn't matter whether or not they get there. It's basically where we think they're going. It's just appearances. So this would say, as x goes to 1, y appears to be going to 2. That's your limit. So a hole in a graph doesn't negate the fact that there is a limit. You may have reached before you reach yours.